We are still working on chapter R, now section R.3, operations on real numbers. And let's start on textbook, page 16. The topic is opposites and absolute values. First, some definition here. The two numbers are the same distance of 0 but on opposite sides of 0. This is the distance of opposites of a real number. Opposite of a real number. And it's quite simple. You see here, if you have the number 4, negative 4 is the opposite because it's at the same distance from 0 on the other side of the number line. If you have negative 3 over 2, the opposite of negative 3 over 2 is 3 over 2. And this is just that. Is the opposite is the number with a different sign. If you have, let me get more examples here. If you have 2, the opposite is negative 2. If you have negative 3, the opposite is 3. If you have 1,250, the opposite is negative 1,250. What's important here to understand is that the opposite is created or is represented with the negative sign. That means any opposite. If you have a number A, the opposite of A is negative A. So the negative sign is the modifier. That's not a technical term. This is something I like to say. The negative sign will change any number into its opposite. Okay? So the negative sign has this special power of changing any number into its opposite. Another definition, absolute value. And again, is a simple definition, but very important. If A is non-negative, that means is 0 or positive, then absolute value of A equals the same thing, the same number, A. But if A is negative, that means if A is less than 0, then absolute value of A is its opposite. And basically, let's check here the examples. If we have absolute value of 9, absolute value, the representation is this two vertical lines. Absolute value of 9 equals 9. But absolute value of negative 9 is equal also to 9. So this sign here, this function here, absolute value, will just remove any negative signs from the number, right? The result will always be 0 or a positive number. Few examples here for us to work. A. What's the absolute value of negative 2.5? Oh, absolute value of negative 2.5, let me fix this. It's more as a straight line. Is going to be, as I told you, the absolute value function is a function that will remove the sign. So it's equal to 2.5. And that's as simple as that. B, absolute value of 5 over 4. So absolute value removes the negative sign. There's no negative sign here. Is equal to 5 over 4. And let's make a division here, divide the space. C. Now pay attention. Negative absolute value of negative 4. This is tricky. the absolute value function will remove the negative sign, right? We'll remove the negative sign. This is going to be equal to, so, but this negative sign here that's outside the absolute value, it keeps the same. Only the absolute value only removes the negative signs that are inside these two vertical lines, inside the function. So this is equal to negative, and absolute value negative 4 is 4. So the result for letter C is negative 4. Okay? Now work out some practice examples by yourselves, and then after a few minutes we get back to number 1, absolute value of negative 9.2 equals, so the absolute value removes the negative sign, equals 9.2, right? Number 2, absolute value of 7/6. There's no negative sign here to be removed, so it's just 7/6. And 3, again, negative, absolute value of negative 2. Absolute value only removes the negative sign that's inside this vertical lines. So this one keeps the same, negative, and absolute value of negative 2, 2. Right? Okay, okay, okay. Let's move on. Now let's add real numbers. To add two numbers with the same sign, just add the absolute values and apply the common sign to the sum. I think this is pretty much something that we all know how to do. And to add two numbers with different signs, subtract the smaller absolute value from the larger absolute value, then applying the sign of the number having the larger absolute value. And let's see how to do using some examples. Well, if you have negative 2 and you add negative 6, both have the same sign, negative sign, right? So you just add the numbers and keep the sign, right? Negative 8. B. Now you have negative 10.3. You add to 13.8. See, the signs are different. The signs are different. So you get the larger one, subtract from the smaller one, and keep the sign of the larger one. 13.8 minus 10.3 is 3.5, and you keep the positive sign. Let's work on letter C, and letter C is a little bit trickier. The first ones, letter A and letter B, are kind of simple, but now we have two fractions, and we have 5/6 plus negative 1/4. And first thing we're gonna do, check this one here. Let's change this into a fraction with just one numerator and one denominator. And how do we do this? this number here is the integer part of the fraction, right? So 1 times 4, 4 plus 1, 5. So this is going to be equal. Let's repeat, 5 over 6 plus negative 1 times 4 plus 1, 5 over 4. Now we need to find the least common denominator. Least common denominator. One way of finding it is starting from the smaller denominator, 4. Add another 4, 8. Add another 4, 12. 12 is 2 times 6, so the least common denominator, 12. Okay, this is one way of doing this. We have to change the fraction and make both numbers with the same denominator. So multiply here by 2 to have 12, right? And we have to multiply on the top as well. And multiply here by 3 and on the top as well by 3. Okay. Then we will have, let's erase this. We will have 2 times 5, 10 over 12 plus negative 3 times 5, 15 over 3 times 4, 12. They all have the same denominator. We can work out like this. Draw this long bar, 12 here, 10 plus negative 15. And now you can identify which one is has a greater absolute value, right? 15 is greater than 10, so we will do 15 minus 10, 5, and we'll keep the sign of the greater one, negative. So all this is equal to negative 5 over 12. This is the right answer. All right, now check the practice. Try this exercises by yourselves, and then we will be back. Number 4. We have negative 4 plus negative 1. Well, they both have the same sign. We add negative 4 plus 1, 5, and keep the sign. Great. 5. Negative 2.6 plus 1.8. They have different signs. Get the larger one, 2.6, subtract from 1.8. 2.6 minus 1.8 is going to be 0.8, right? 0.8. And the sign will be the same one of the larger, which is negative. Negative 0.8. And now this is the trickier one, because have a rational numbers, Let's try negative 1 plus negative 3 over 7. Okay, let's make this into a fraction as well. Negative 1 over 1, and put all the signs on the top. Let's put all the signs on the top. negative 1 over 1 plus negative 3 over 7. The least common denominator, let's write down here, least common denominator. You have 1 and 7, the least common denominator is going to be 7, right? So use the least common denominator. Equal, draw a big bar here, the least common denominator on the bottom, and we have to multiply by 7 on the top and on the bottom, and on the top. Negative 1 times 7, negative 7, oops, negative 1 times 7, negative 7, plus, and we don't need to multiply anything here, it's times 1, right? Negative 3. Perfect. Now they have the same sign. We add 7 plus 3, 10. We keep the sign negative of both, and we use the denominator, the least common denominator. This is the right answer. Let's move on. Now, subtraction. And if you have A and B, real numbers, then A minus B equals A plus negative B. Well, this is kind of what we've been doing. Let's check these examples here. A, negative 13 minus 5 is going to be negative 13 plus negative 5. So we add the numbers, the absolute values, 18, and you keep the sign of both, negative. B, 2.7 minus negative 3.8 is going to be equal to 2.7, right? If you have negative in front of this, remember I told you the negative sign is the modifier. The negative sign is the modifier. It makes this number here the opposite. So let's change. Now this is going to be the opposite of negative, is positive. And the opposite of a negative 3.8 is positive 3.8. 2.7 plus 3.8 is 6.5. And this letter C, the trickier one, let me erase all this. Letter C is going to be, and it's going to be tricky because we need to find the least common denominator. 5 over 2 minus 4, 2 over 3. 4 is the integer part. Let's change this. Repeat, 5 over 2 minus 4 times 3, 12, plus 2, 14 over 3. And what's going to be the least common denominator? We have 2 here, 3 here, 2 times 3, 6. Multiply to make 6, multiply by 3. To make 6, multiply by 2. Draw a long bar here, write down the least common denominator, and on the top here you have 3 times 5, 15, minus 2 times 14, 28. And we'll change this number that follows the negative sign into the opposite of it. The opposite of 28 is negative 28. So it's 15 plus negative 28 over 6. And now we add negative 28 is the greater one, 28 is the greater absolute value. So we will subtract 28 minus 15, 13, and we keep the sign of the greater one. Negative 13 over 6. And this is the answer. Keep in mind that we are doing this step by step, but once you have you understand these concepts, you can do it slightly faster, and it's going to be natural. Okay, now practice for you try by yourselves, and then after a few minutes we get back and check. Number 7, negative 9 minus 8 equals, we will do like this, negative 9 plus negative 8, 9 plus 8, 17, negative, right? Number 8, 1.1 minus negative 4.2. So the negative sign is the modifier here, 1.1 plus the negative sign. We modify this into its opposite. Opposite of negative 4.2 is positive 4.2. And 1.1 plus 4.2, 5.3. And the last one, 1 over 6 minus 2 1/4 equals 1 over 6 minus 2 times 4, 8 plus 1, 9 over 4. And the least common denominator here is going to be 12. To make 12, multiply by 2 here and multiply by 3 there. And we will have, draw this long line, bar, 12, the least common denominator, 2 times 1, 2, minus 3 times 9, 27. Almost there. This negative sign here is the modifier. So let's write down here 12 and 2. The opposite of 27 is negative 27. That means 27 minus 2, 25, and keep the sign of 27. This is the right answer. Nice, well done. Let's go to the activity of today. Open Teams, find the activity addition and subtraction of real numbers, and open it. And you need to have a piece of paper. You're going to work out your calculations, and on Teams, actually on Microsoft Forms, Teams will send you to Microsoft Forms. You will just add the answers. You reply just typing the final answers.